everyone, I am Anjan and welcome to the 8th video tutorial of the Verilog course series. In this video, you will be getting to know how the ripple carry adder works and how to design a Verilog code for ripple carry adder. For a better understanding, I split the video into 3 parts, that is pre-coding part, coding part and the post-coding part. Now let's move on to the pre-coding part. In the pre-coding part, you will be seeing the circuit diagram of the ripple carry adder, which seems to be simply like a ripple adder which is connected to 4 2:1 muxes, and each 4:1 muxes having an inputs, that is a NOT gate connected to the input A, that is A0, either it is A0, A1 or A2 or A3, and I have given an input D which is connected to the input C in case of ripple adder. And if you don't watch my video, just check out my video on StarSky's YouTube channel playlist of mine. And here, if you coming to the functionality of ripple carry adder, it can act as both ripple adder and a ripple subtractor depending on the input D. Here D, if D equal to 0, then it will act, the ripple carry adder will act as subtractor. D equal to 0, then it will act as adder. And if it equal to 1, it will act as subtractor. Here it is. If D equal to 0, then it will act as adder, and if D equal to 1, then it will act as subtractor. And now let's move on to the coding part of our ripple carry adder. In the coding part, here is my ripple carry adder, which is the module name, and here is my port list, and here are my inputs, output wires. Here wires C1, C2, C3 are my wires, where they are not mentioned in the port list because they are just driving the values from one full bit adder to one full adder to the another full adder, that is here C1, C2, C3. But I didn't mention C4 because it's just an output, not any driving value. And if you are mentioned, I didn't mention A0, A1, A2, A3 in the circuit diagram. They are the values here after NOT gate. A0 is no, here not, here it is. This is the value of A0, this is the value of A1, A2 and A3. You will be seeing in the next slide. Here it is. I declared them as register because they are being used here in the always block. Always at the rate, the sensitivity list is D, because if D changes, the values of the A0 and C0 will be changed. If D equal to 1, that means it is true, then this function will be generated. Means D equal to 1 means that is subtraction. Subtraction means A0 equal to negation of A, that is not of A0, and it will take the values of this one. A0 1, this one will be taken and this will be omitted. This is similar to the all the cases. Else, that means D equal to 0, that means addition operation will work, and this will be the condition, and C0 equal to 0 will be taken as an input. And I will be using this to the, I instantiated the ripple adder here with the name ripple adder 0. And if you observe my previous video, you can know that in that video I mentioned capital A 0 and capital A1 as the port list there. So I here instantiated their names, and I imported the values of A0, small a0, small a1 and small a2 like this. I given the values to it, and I will be getting the simulation for that in the tool in the next coming minutes. Now let's move on to the post coding part. Here is my repliator code. If you observe, I use capital A, and I instantiated full adder in the repliator code. I written the full adder code here. Those are covered in my previous videos. And here is the ripple carry adder, where I instantiated the ripple adder with the name ripple adder 0. It is the same code which I have shown in the presentation, and to save the time I already pre-simulated it. Here is my simulation, but I didn't give any values to show you how it works. Now I will be giving the values, like first of all I will be giving the operation D, that is D equal to, let's say, addition, so that we should give the value 0, pass on the value 0. And I will be giving the value A0 as 0, B0 as 1. Even as 1. Like that I will be doing the similar kind of thing, so that I will be getting the value 1 itself, because 1 plus 0 is 0. Wait, A2 I given 0, B2 I will be giving 1, and for change I will be giving A3 as 1 and B3 as 0, so that I will be getting the sum S0, S1, S2, S3 as 1, 1, 1, and C4, C1, C2, C3 as 0. Now let's simulate it for 10 nanoseconds. Here I got it. C4, where? Here it is. Here S0, S1, S2, S3 as 1, and C4 as 0. Coming to C1, C2, C3, why are given Z means because they are just driving the values. They are not mentioning any values, as they are in the ripple carry adder. They can be Z. There is no problem, but our output should be 1, 1, 0. Here, this is the main scenario. And now let's move on to the schematic part, so that you can be sure that whether my output is correct or not. I'll be showing my schematic too. Here is my schematic, and if you closely observe, I will maximize it. A0 is given to the multiplexer by means of two inputs, that is through NOT gate and through driving the default value, and similar to the A2, A3. These multiplexers are given to a ripple adder, and B0, B1, B2, B3 are similar, and D is the main case, that is the selection line to the multiplexers, whether to choose 0 or 1. And here are my outputs, that is C4, S0, S1, S2, S3. And if you observe, why I got Z means it is there in the ripple adder. It is the circuit in between. I will show. If I will show, you will get clarity. I just instantiated the value of ripple adder, but I didn't mention the values within the ripple adder in the circuit. Ripple adder. Here it is. C0, C1, C2 are the values which are passing from this full adder to this full adder, and it is the values within the ripple adder which I instantiated it. So they are shown Z. If I don't instantiate and I write the whole code here, I will be getting those values too. Okay, that's it. If you like the video, do like to share to your friends and subscribe to the Start Scratch. Thank you.